Let's take a look at another example here where we're asked to solve a linear function for a particular variable. So notice here we're given 4x minus 3y is equal to 7, and we want to solve for y. But notice this equation, it has two variables in it, and sometimes that happens. It's okay, all right? Sometimes you might have an equation that has nothing but letters. There are no numbers, but we can still solve for a particular variable by using inverse operations. Okay, so our goal here is to solve for y, which means eventually I want to get down so the equation is just y equals, okay, and everything else will be on one side of the equal sign. So to do that, I'm going to choose to keep y on the left-hand side of the equation and move all the other terms to the other side. So we're going to do that by using inverse operations. Okay, we have to move this term 4x over to the right-hand side. So to undo that, the inverse of positive 4x is minus 4x. Oops, rewrite that a little bit neater. Okay. And because this is an equation, whatever we do to one side, we have to make sure we do the same thing to the other side. So this cancels out and becomes 0 on the left-hand side. So we're left with negative 3y on the left. And on the right, I can't combine 7 and negative 4x because they are not like terms. So what I end up with on the right is just 7 minus 4x. Okay? Now our last step is to divide out this negative 3. So negative 3 is attached to y by multiplication. So its inverse operation is division. So I'm going to divide out that negative 3. That cancels out and becomes 1. So I'm left with 1y. But again, because this is an equation, whatever I do to one side, I got to make sure I do the same thing to the other side. So we have to divide out this entire right-hand side by negative 3. Okay, so on the left here, we're left with y, and on the right, we're left with 7 minus 4x over negative 3. Now, most of the time, you don't want to leave your denominator with a negative sign. So what you can do is you can divide out that negative sign. So if I multiply this fraction by negative 1 over negative 1, would you agree with me that I'm basically multiplying this expression by 1? Which doesn't change the value, okay? So negative 1 over 1, you could think of negative 1 over 1, that's the same thing as 1. And 1 times anything is just itself. So what I'm going to do is I'm going to multiply the numerator and the denominator by negative 1 to basically simplify out that negative 1 in the denominator. So what I end up having on the numerator is negative 1 times positive 7 is negative 7. Negative 1 times negative 4x is 4x. And then on the bottom, negative 1 times negative 3 is positive 3. And you can leave your answer like this, or sometimes students like to rewrite the order. So the commutative property of addition says it doesn't matter the order. We can do negative 7 plus 4x, or we can do 4x minus 7. It means the same thing. Right? So this is correct, but this is also correct. And now we've just solved for y. And it just so happens that y is still in terms of x, and that's okay. All right?